Okay, so this is the briefing video for the paracetamol experiment, and what I'll do is give you an overview of what you're doing in the experiment, why you're doing it, and key bits about the sort of timing and planning of the experiment, and tips for how to perform the experiment safely as well. So if I talk through to start with what you're doing in this experiment, what you're doing is you're mixing together 4-aminophenol, which has this amine group here, acetic and hydride. So you've got two anhydride functional groups, and through a sort of a nucleophilic substitution reaction, you're making an amide bond. So the amine is reacting with one of these two carbonyl groups to make an amide bond, and then you're sort of kicking out sort of the rest of this portion of acetic anhydride, which becomes the acetic acid byproduct of this reaction. And so through doing this experiment and making paracetamol, you'll get repeated practice of these particular lab skills, but in particular you'll also learn and introduce these sort of new skills here. Heating under reflux is a method of how we sort of tend to heat reactions in organic chemistry, so they can where you sort of need to heat the reaction to allow sort of the key bond forming processes to have enough energy to occur, and also melting point determination, which you'll do at the end of the experiment, which can be used to sort of verify that you've made paracetamol and also that it has the required purity. In the associated theory video, we'll sort of explain to you how we sort of know or decide when we want to sort of heat reactions or cool reactions, or are simply okay to allow them to stir at room temperature. Okay, so do watch the following pre-lab videos, including the theory video, but also videos that will cover the lab techniques, such as how you would actually set up and perform the key sort of lab techniques, including how to set up a reaction under reflux. So this is how the reaction should approximately plan out for your day. Do read the script to sort of get a better idea of how long you think things will take for you based on your sort of abilities. But roughly speaking, it should have this sort of structure where the whole experiment can be completed comfortably within a full day. In the morning session, what you'll be doing is we'll be setting up and heating your reaction under reflux, and the whole reflux itself takes about 15 sort of minutes of heating to make paracetamol. So all in all, sort of setting up, heating under reflux, cooling down your reaction should take approximately 2 hours for you to complete. And then at the end of the reflux, you should have made paracetamol, and it's about simply trying to sort of isolate the paracetamol and purify it further from your sort of byproducts and starter materials. So what will happen is paracetamol will crash out as a precipitate when you cool your reaction mixture down. So then you'll sort of filter the mixture to isolate crude paracetamol. This is usually a good time to take a break, so it times in nicely with your lunch break. And then following in the afternoon session, what you can do is you can sort of work on sort of further purifying your paracetamol by a recrystallization in water, and then when you sort of filter and dry the paracetamol, you should have some pure paracetamol, which you will then sort of analyze using TLC and further techniques like infrared melting point. But there is you should be able to do this comfortably within a few hours, but there is some extra time that's sort of banked in there as well if should you need it. Do make sure you are familiar with the hazards of the experiment. Remember, these are all in the lab scripts as well. And as part of the pre-lab exercises, we'll be making sure that you're fully aware of some of the key hazards of what you're going to be doing. Also want to stress is that when you get to using some of these chemicals or techniques and you're unfamiliar or you've forgotten about what the key hazards are, that's okay, but do make sure you then look back into the script where you can find all the hazard information as well, and make sure you refresh your memory and your knowledge of what the key hazards are, the precautions you need to take, and how you should dispose of things safely. Okay, do make sure you do double check on how to what the hazards are of any of the chemicals you're using just before you're using them, and they're all in the script for you to kind of look back and refer to as you're working your way through the experiment. These are some of the key hazards that you're going to be working with through the paracetamol experiment. So these chemicals here, acetic anhydride, the solvents, ethyl acetate, petroleum ether, are highly flammable. So do make sure you don't have any sort of heat sources, Bunsen burners, for example, nearby that could sort of ignite these flammable materials. Also, acetic acid, acetic anhydride, they're also corrosive as well. So do make sure that you are sort of wearing gloves as well when you're handling these chemicals as well. And you do mop up the spills as well quickly if you do spill any of the material, so nobody else would unwittingly come in contact with them and sort of have a sort of skin burn as well through contact with the chemicals. Finally, for this briefing video, I just want to cover some key tips to help ensure that you are this experiment runs smoothly for you. So when you're setting up the reflux apparatus, you've got a number of different pieces of equipment and glassware that you're using. So it's about making sure that you set everything up correctly and in a safe way as well. So in your lab drawers, you've got a number of different sort of round bottom flasks and condensers that you can use, but you need to make sure that you're using the correct size flask and condenser, so the neck between the flask and condenser fits very snugly. There's no gaps of air between them, so when you're heating your reaction mixture, the vapors from the solvents can't escape. They should all be rising through the middle of the condenser, where the water from the condenser will cool it down back into the flask. Okay, so flasks and condensers have joint sizes like B14 or B19, for example. Make sure that you're using the matching flask and condenser sizes so that there's no gaps. If you don't have a flask or condensers that match up completely in the correct way, so you don't have two B14s or two B19s, for example, you do have adapters in your drawers as well that allow you to use different size flasks and condensers with each other to ensure that there's no gaps. The next point I want to highlight as well is make sure you do clamp your reflux apparatus in the correct place. So you'll see in the picture in your script and here on the in the slide, you clamp the reflux around the neck of the flask, and this is so that if you need to take your flask, your apparatus off the heat, you can sort of lift your flask off the heat safely if it's around the neck of the flask. Because your condenser is just attached through the top, that will also move upwards for you when you do so. If you clamp your flask around the condenser and you were then to try to lift your reflux apparatus, well then you'll lift your condenser, but your round bottom flask will just simply fall off the bottom, and your solution with it as your reaction, which will be hot, will sort of fall off the bottom, potentially break the glass, and then you've got sort of hot, chemicals that have been heated, but with nothing to sort of keep them contained. And the final sort of point regarding this setup of the reflux apparatus is to make sure that when you attach your tubing to the condenser, that you make sure that the water has no leaks. So here, what you don't want to have is the water to be leaking out between the joint of the tubing and the condenser and onto your electrical hot plate. That's quite a significant hazard which could cause a fire. So something I recommend doing is, before you actually start heating your reflux, just take your condenser off your reflux apparatus to one side, off the hot plate, check that the water isn't leaking. If it is, do look at using cable ties or changing your tubing. But if you do spill any water, you spill it onto the fume hood floor, and then make sure everything is not leaking before you sort of fit it back onto your reflux apparatus. Okay, and then the next sort of tip we have here is just around the section of the experiment where you sort of cool your reaction after the reflux. You're supposed to get a white precipitate that comes out that you filter of crude paracetamol. Often what happens is you need to actually cool your reaction in a ice bowl and scratch it with a glass rod. And by scratching it with a glass rod, you induce the crystallization to occur. So don't worry if you cool your reaction and you don't get any precipitate forming straight away. It's quite likely you'll just need to scratch the flask with a glass rod, and then you should get some solid forming. And then the final tip for this experiment is regarding the melting point. So what will happen is you'll take a small sample of your pure paracetamol, you'll put it into a very small thin tube called a melting point tube, and then you'll heat this in a melting point apparatus and watch and observe the temperature over which your sample will melt. Now, the key thing here with regarding a melting point is that you're not recording a single point at which your sample melts. It's a melting point range. So for when you start seeing the sample start to melt, that's the first temperature that you record, to which it sort of fully melts into a liquid. That's the final temperature that you record. And what you need to record in your lab book is kind of this melting point range from the first melting to when it's completely melting, okay, rather than a single point. And if your sample is pure, then this melting point range should be quite small, within 1 or 2 degrees, and close to the expected melting point range of paracetamol. If your sample is impure, then actually that range will be larger than a couple of degrees as well. So this is how melting point is used to sort of tell you how pure your sample is. Okay, so that's the briefing video for the paracetamol experiment. Do make sure that you continue and watch the other videos and read the scripts to complete the pre-lab exercises, and then you're in a place where you can sort of answer the pre-lab test that you need to complete before starting the experiment.